Look at that. Dead on. Doesn't even budge. That's a perfect meter right there. This is going to be a very special video for Mr. Fungus, who had asked about doing some mechanical stress testing of this meter. So his whole concern with this is because this meter has this problem where it's susceptible to a magnetic force, in this case just a simple hanger, and how it can change the state of the internal relay. So for example, right now I have that relay set in the wrong position. So here I have a standard 120 volt outlet, and you can see if I attach that to this meter, we're reading 4.1 volt. There you go. All I've done is swipe the magnet. If I change this back the other way, there you go. Change the state the other way. And I've showed you in a previous video how I could actually use a hanger off of one of my other meters and have it probably 3/4 of an inch away from this thing, and it'd still change the state of it. So I think rather than play around with the AC line, we can probably do this with just our Bryman meter, because again, I believe all that's happening is we're changing the state of this relay right here, and we're just basically changing this path to go through these diodes. So what's going to happen is I switch this thing in, I expect we're going to get a lower impedance path than what we would if the relay were in its normal state. So if we hook this thing up, there you can see it reads an open, and right there again I just had it change states, and you can see it's reading about 7.5 meg. There it just changed states again, back to an open. So we could detect this fault even with the meter turned off, just using another meter to look at the input impedance. So what I'm going to do is we'll turn this thing on. So right now the relay is in the correct state. I'm going to turn it off. And now what I'm going to do is do some drop testing. We'll just leave the Bryman meter attached to this. And of course, he didn't really have any criteria for this. He was saying basically drop it across some screwdriver. It's like, what the hell does that mean? So I'm going to drop this thing from, I don't know, this is about a foot or so off of the bench. And we'll try this in a few different axes. And let's just see if the Bryman ever picks up a change. Be a little tough to do it on the face. I'll have to disconnect it. And you can see the relay did not change states at all. So now let's just go through and we'll do a quick check with the meter. Again, I assume it's fine after this, but you never know. Again, we'll just start with resistance, and this will be a 0.5 ohm, this will be a 1 ohm, 50 ohms, 100 ohms, 1K, 10K, 100K, 1 meg, 10 meg. This should be roughly 500 degrees, 150 picofarads, 1 nanofarad, 0.1 microfarads, 1 microfarad, 10 microfarads, 100 microfarads. And here's our infamous bug. So again, I have to turn the meter to the AC mode, and you can see now it's displaying the 60 hertz. And here's our 60 hertz, and 30 hertz, 15 hertz, 120, 240. This will be roughly 5 volts. And this should read roughly 5 volts. Should be 2.5 and 3.6. And this should read 2.5, and this should read 2.5 and 2.5 at 30 Hertz. Let's just quickly check the diode. So again, this is an open. Here's a short. And let's just check a single diode. Looks fine. And here's 3 diodes. So it doesn't look like we damaged the meter in any way. I'm sure that you could do something to cause that meter to change states. I just don't know what it would take to have that happen. Again, I supplied the part number for the relay that's actually used in this meter. I had recommended that that person just buy, some number of relays and run their own test. There's probably also application notes out there that give you some idea on what it would take from a shock standpoint. Again, this thing being stuck in a rubber housing the way it is, that's going to play into it. And also the weight of the meter. Here I have this rubber anti-static mat and also this rubber boot. So it's going to be a little different than dropping it onto concrete, and height-wise will make a big difference. So there you go. I'm not really sure what kind of information you're going to glean out of that. Hopefully you found it useful. Later.